has everything to do with technology. Everything that we do in technology is for data. Everything we do in technology is for data. Everything we do around technology is done around data. So that is why it is very important. And I've already said it, the very first language or the very first skill that you need is SQL, right? And that's what we're going through SQL, right? So we're going to start now, and we have 12 chapters to go, and don't worry, we're going to cover, right? Don't worry. I've done this before. I've done it multiple times. We're going to cover. So the first thing I want to do is do an introduction to database, right? Do an introduction to, we've talked about data already. We said data is any form of raw aspect or raw unit of what, of information or raw unit of data, right? And it can come from any source, right? It can come from any source. It could be an employee's information. It could be an information for a from a network. It could be an information for people's salary. It could be an information from even Facebook, Google, any form. It can be from any form. It can be information from movies or from conversations that people have on the street, right? Or it can even be from your heartbeat, right? It can be an information from your heartbeat measured by a smart wristwatch, or from music from your phone, or from calls that you make. So data can come from any form, right? But then there's something that, as much as we talk about data, right, there's the way to actually keep this data. There's the way to manage this data, and that is what we want to go through. How do we manage data? How do we look at data and make sure that this data is well managed and we can get the best out of it, right? And that is the essence of this program, right? The essence of this program is to teach you how to manage data, how to look at data and understand what it's saying, how to use data, right? Also, so we're going to be starting by saying what is a database, right? And basically, when you talk about what a database is, right? Hold on, I mean, just this guy. Hold on, please. Awesome. Awesome. You can see my screen better right now?
Yes, sir.
Yes. All right. So what is the database, right? So it says every organization needs has some form of information, right? Or has information needs, right? And a library, take for example, keeps list of members, books, due date, and fines. A company saves need to save the information about its employees, department, and salary. And a online store needs to store information about its products, its orders, customers, and so on. All of these are called data, right? We've talked about data, we've flogged data enough. All of these are called data. It says this piece of information can be stored in different formats, such as hard copy documents, right? In a filing cabinet. How many of you went to before banks became the Indian in Nigeria, right? Before banks became digitalized, that's the word I'm looking for, right? Before banks became digitalized, how many of you ever went to a bank in, say, in the 90s? How many of you? I'm sure most people here are not even, were you born at that time? How many of you? You guys are the GTB generation, back. Awesome. Anybody? Vivian? Hello? Hello?
I think you're cracking. That's why. Hello, sir.
Can you hear me now?
Yeah, we can. I can hear you better than before. No.
Okay. Sorry, I was using a nylon to cover the network. I didn't know. But you can hear me better now, right?
Yes, sir.
Awesome. So I was
Yes,
asking
we can
that
hear you.
how many of you had a visit to the bank in the 90s when banks were not digitalized? How many of you had the opportunity to enter into a bank? Say, what banks were there? There were the First Bank, for example, Union Bank, Wema Bank, National Bank, not GTV Bank, right? I remember then my father worked in the bank. How many of you, Vivian, were you opportune, Trisha, Ibukun, were you even born then, sir? Right?
I was not.
Right? Of course, right? I remember that I was very young then, right? And I know that I used to follow my father to, on weekends or Friday kind of work. I'm saying maybe when I was maybe age 2, age 3, right? But what I can remember from all of that is that you see that the people go to the bank and spend a whole lot of time just to withdraw their money, right? Of course, there are very few people who own bank accounts at that time. And then even the people who own bank accounts at that time had to, everything was paper. Everything was done through paper. You want to fill a form, it is paper. The banks want to give you anything, it is paper. You want to withdraw your account, they will bring a file that contains all your transactions, all your information. So anytime you remove 5,000 from your account, right, they would have to write it down that you've removed 5,000. Anytime you saved 100,000, right? Of course, at that time, millions was not the ending, right? It was still people in the hundreds and all that. People add money in the hundreds. If few people add millions at that time, right? So you write it down and say that I deposited 100. So they'll put it in a spreadsheet form, right? And file it in your file. So everybody add files, and I'm sure you guys have seen those file cabinets, those iron file cabinets that some organizations still use to keep data. I don't know what they are doing with those things. Those things are supposed to be thrown away or used to fill something, or converted to spoons so that we can use it to use, right? Right. So those were that was how data was stored before the advent of computer, before computer became the anything that everybody uses, before digitalization of everything happened, right? So it was the same thing at that time. It was the same thing that we're talking about, right? So data was stored in hard copy documents. So you remember then that when an organization experience fire outbreak, right, and everything gets burnt, right, what it means is that most of those organizations go bankrupt, right? They just cease to exist because there is no backup. There is no backup of information to say that this is our information and all of that, right? So most of those organizations just go out of existence because people do not have. So imagine that a bank that gives information in paper, right, hard copies, right, gets burnt. How do you tell them that? How do they reconcile that what you have is 5,000? Some people will just come and say, no, I don't. It's not 5,000 that I had in my account. Meanwhile, it's 5,000. But say, I had 50,000, right? But there's no way for them to reconcile to say that, no, this is what you have and this is what you do not have, right? So a whole lot of them went bankrupt because they had to pay out what people didn't have to people, and it was crazy. But all of a sudden, right? One guy, his name is Dr. E.F. Code, right? Dr. E.F. Code. Dr. E.F. Code, right? Dr. E.F. Code in 1970 postulated and said that data should be stored in what? Data should be stored in rows and columns. Please let me know if you can see my terrible handwriting, right? So he said data can be stored in rows and columns. So he wrote a paper then, right? That data can be stored in rows and columns. If you read the article that I sent to you, how many of you read my article? How many of you read my article? Hello? Can you hear me? Are we there?
Cutting out, sir.
Yes, sir.
Ibuku, can you hear me clearly?
Yes, I can.
Trisha, can you hear me clearly?
Yes, I can.
Vivian, I think your network is terrible. I'm actually using the fastest network in Nigeria at the moment. Okay, not the fastest, but somewhat kind of very fast, right? So please just try and adjust your network or adjust your position so that you can hear me clearly, right? I don't want you to miss any part of this. Awesome. So Dr. E.F. Code postulated in 1970 that data should be stored in rows and columns, right? And I in the article that I sent to you, there's a link that I provided in that article that points to the the article you wrote actually, right? Because it's a published article. And it made a case that the way data has been stored, right, does not allow for it to be stored properly, does not allow for it to be manipulated properly, does not allow for it to be analyzed, does not allow for it to be engaging, right? And he said that if we store data in rows and columns, we'll be able to get more out of data, right? And he called that relations, right? So he said data should be stored in relations, right? Relations. And I'm going to explain what that means. He said data should be stored in relations. Actually, the word relations means table, right? And table is made up of what? Rows and columns. Do you get the idea now? Right? So the word relations means table, right? And table is made up of what? Rows and columns. So therefore, a relation is what? Is a table. Are you following me? Now, it says to manage databases, right? So we're talking about database management now. So it says a database, right? So let's finish this, right? It says a database is an organized collection of information. So when anybody asks you and say, what is a database, right? All you just need to tell them is that a database is an organized collection of information. Basically, that's what it is, right? People think it's something very complex, but no, it's not, right? It's just an organized collection of information. And when we use the word organized, right, information can be information. Of course, you can generate information about almost any topic and everything on earth, right? Everything can serve as a data point. But when you are creating a database, the information in a database, in a particular database A, must be related information, right? And when we talk about related information, it means that there are data that can be related to each other to get meaningful information out of them, right? So take, for example, you're storing data about say, products in a store, right? So you're storing about information about a store, and a store that keeps products, that keeps orders, that keeps customers information and all of that, right? And in that same database, you have information about police. How does products and police relate to each other? Are you following me? So the information that you want to keep, right? Products can be ordered, so they are related. Customers order products. Are you following me? Are you following the logic? Right? Look at this example here, right? Products can be ordered, right? There's a relationship between products and orders, right? Which means that for you to buy a product, you must order it. And who is ordering for that product? Customer. So a customer will order for a product. Can you see how they are related? And that is what we are talking about. These data have to be related. They have to be able to relate with each other to get an information. So when you say, who bought this Gucci bag, right? Who bought this Gucci bag? You say customer A ordered for product. What product did the person buy? A Gucci bag. Can you see how related they are? So when you talk about a database is an organized collection of information. It's as simple as that, right? Now, database management. It says to manage databases. Please, if you have questions, you can write your questions down so that at the end of the class, I can take your questions and answer them, right? So when you have a question, when a question pops to your mind, just pen it down so that we can answer those questions at the end of class. All right. So now it says database management systems, right? It says to manage databases, you need a database management system, right? You need a database management system. We call database management system DBMS. Hold on, please. All right, so I'm just trying to look for my eraser here. Awesome. All right, so we call any software, right? And I'm going to explain so that you can understand. So DBMS are called, database management system are called DBMS, right? Please don't forget that, DBMS. Now it says a DBMS is a program that stores, so that's one. So it does one, stores, two, retrieve, and three, modifies. So a DBMS is a program. When we talk about program now, the word application should come to mind. A software application, right? A software application should come to mind. A software application that stores, retrieves, and modifies data in databases on what? On request. Now, I'm going to talk about the key points that you have there. So one of the major functions of a DBMS is that it must be able to store information. It must be able to store data. That is, it must be able to do what we call data warehousing, right? So storing data storage, it must be able to perform or be a storage, which is called data what? Data warehousing, right? It must be able to store data. Then it must be able to retrieve data, right? Second is data retrieval, right? Retrieve data, right? That is, you want to query data. That's what we call data query, right? So you query the data, you query that information, and it gives you the information that you require, right? So you ask the data a question and say, tell me about this, and it gives you an information, right? And modify. The last one is data manipulation. Data manipulation. That is modification of data, right? So which means that for a database for a DBMS to be a DBMS, you must be able to modify the data inside of it. Hold on, people. You must be able to use it to modify information. You must be able to use it to modify information. And now it says in databases on request, which means that it is not that I'm going to query the database today and it's going to give me a reply in, say, 2 years' time, right? No, you must be able to do all of these things on what? On request. Request means that at this point in time T, right? At this point of time T. And let us look at all of this, right? Let's look at a global example. Let's look at a global example. Please, I hope you're following me. Please note down things. Don't just listen to me. Yes, this video is going to be available after class, right? I'm going to share the link with you so that you can download and watch again, right? But please note down informations, note down things. You understand how you learn better. So please, I don't want you to just attend class and this has to be your last time to learning SQL. I want you to put your mind to it and get it right? So let's take for example, right? Let me use Patricia as an example. So Patricia needs to know, right? She has a question. She needs to know what is the price of dollars in exchange to Naira. Hold on. Dollars in exchange to Naira in the forex market today. So Patricia she's a forex trader and she wants to know what is the price of dollar in exchange to Naira in the forex market today, right? So how does she know, right? So take for example, right? This is what Patricia would do, and this is what everybody does every day, right? So you can, in your mind, relate this to what you do. So Patricia is going to open google.com, right? She's going to open google.com, and in that search bar that google.com has, she's going to say, she's going to type this question there. What is the price of dollar in exchange to Naira in the forex market today? And what happens? In less than 2 seconds, right? If she has a good network, of course. In less than 2 seconds, what does she have? She has a plethora of information. She has what? She has a plethora of information staring right back at her. These informations are derived from, okay. These informations are all derived from the database, right? But let us not even take it to the database. What does she have? She has a plethora of information right in front of her, pointing her to several resources for the question she has asked. How many of you have seen this before? How many of you have seen this before? How many of you have used, of course, I know everybody here has in one way or the other used Google before. All right. How many of us have done this before? Ibukun, IBK, Ibukun, Patricia, Vivian. Welcome, Anoluapo. Can you hear me, please? Let me know if you can hear me.
Yes, I
Welcome.
can hear you very well.
You came late. You will pay us for coming late. Welcome. So, how many of us can do this? How many of us have done this? You've asked Google a question before and Google sends you information, right? This is what we actually do almost every day, right? We have questions that we send and we generate. Google says that they generate about 2 billion, I think about 2 billion questions every minute or thereabout, right? Now, I'm not sure about that statistics, but you can read about it, right? Now, what does that mean, right? This is what happened in the database. This is what happened in the system. Of course, let me just clean this off so I can explain to you what happened, right? So, this is Patricia on our system, right? Let's call this our computer, right? This is our computer where she is using, hold on, this is becoming messy. Just follow me, you would understand what I'm trying to do. So this is Patricia on our system. This is our keyboard, right? So here she used google.com, right? She visited google.com, right? So this is Patricia, right? So we'll just put her name here, Pat, right? And Pat here is called, we call her a client, right? Because she's using a client system. A client system is a query system, right? A system that sends, that queries a database, right? So Patricia here used google.com to ask this question. All right. Patricia here used this computer, right? It could be a computer, it could be a phone, it could be a tab, it could be anything that can connect to the internet and use a browser, right? So that's what we call a client. A client system now is any device that has the ability to use the internet, that is to connect to the internet through a browser, right? Now, so she connects to the internet, of course, maybe through Glo, through MTN, through whatever network, right? And she sends that query. Of course, she does not know. She just believes that there is a God somewhere, all right? There's a system somewhere, right, that would give her a reply. So she sends that query out, hoping that she sends it to Google, right? Of course, Google as a company that is providing that service. So she sends that query to Google. Now, in Google, this is Google as a company, right? Let's draw Google as a company. Google is a massive company. Google is a massive company that has several databases, right? So we're just going to draw these databases as buckets of yeah, just like this, right? So they have these buckets. All of these are, so I'm going to call this database 1, database 2, database 3, database 4, database 5, database 6, database 7, database 8, right? So they have all these databases, right? And she sent this question. So she sent a question, right, to an unknown location. Or how many of you know where Google is? Of course, we know that Google is in America, and we know that it's in California, all right? But we don't know where the data are actually stored. So you send the information to an unknown source, right? And with belief, you know that it's going to, we have faith in this world, right? And we believe that we're going to get a response. So she sent a query, right? So we'll call that query so that we begin to get familiar with the term. So she sent a query into the database, of course, database in an unknown location. And what does she get in return? Right? The database replies that and says, hey, Patricia, I have a plethora of information for you concerning what you asked. Right? So she sends a query, and what she gets is a result or several results about the information that she had queried. Right? And this is how a database works. Does she have to wait? No. Did she have to wait for several minutes for her to get results? No. She gets her results instantly. Of course, that is depending on the kind of network she's using. But our response or our ability to get response instantly also relies on the kind of internet network she's using. But most of the time, we have good internet network, and she's able to get a response very fast, right? Now, what she has done is that she has queried the database. It's as simple as that. She has queried and she has interfaced with the database. So she sent a query and she got a response. She sent a query, she got a response, right? And we'll get into the nitty-gritty of it so that you understand what exactly happened inside of that. But that is the process. So anytime you send a query, anytime you query something on Google, on Facebook, on Twitter, on Instagram, on any application, right? Anytime you query and you get a response, right? What you have done is that you have used your application, your client application, to access a server. Of course, this is called the database server, right? Sorry that English. So this is called a database. So Google has what we call a database server, right? All of these databases are on the server, right? So Google has that server that keeps information, and the result gives what information to Patricia. Now, I need to ask you a question. Those information that she got, were they stored on her system before? I need answers to that. Those information, right? Were they stored on our system? Did those information come from our system?
No.
No.
Not
right?
at all.
Not at all, because those informations do not reside on our system. Those information resides on a server somewhere around the world, right? And that because you have the access to internet, you can query these data and get information out of it. So that essentially is the function of a database management system. So this database management system that you have here stores information. Can you see it has performed the function or the ability to, what's the ability to store, right? It has stored, because if it didn't store, it will not be able to retrieve. So we stored, we retrieved, right? Now let's assume that the result she got was that $1 is 411 naira, right? 411 naira. Maybe today is maybe she did this query on 1st of September, right? 1st of September 2021. She got a result of 119, right? And she goes back again on what? On the 3rd of September, right? 219, I mean 2021. And she got that dollar now is now 533 naira to $1 to $1 is $1 to $1 is now 533 naira, right? What does that mean? It means that what happened? There is a change in the information she got. On the 1st of September, she got 411. On the 3rd, she got 533, right? What has happened? It means that somebody somewhere has been able to modify the data, right? Which is another what? Function of a DBMS. So you are able to store, you're able to retrieve, and you are able to what? To modify data on what? On request. Now it says that there are several what? DBMS available in the world. Please let me know if you understood all I've just explained, please. If you understood what I just explained, please let me know. If you understood what I just explained, please Let me know. Hello?
We understand, sir.
All right. Please, I don't want us to delay in response. Let's just respond early so that we can move on as quick as possible. Right? Awesome. 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 Now, it says there are several words DBMS available in the world today. There are several DBMS available in the world today, such as Oracle, right? How many of us have heard about Oracle before? Oracle is said to be the leading technology in database management, right? Of course, they do more than database, but in database management, they are the leading in the world. And MySQL is the next one. Oracle also owns MySQL, right? So we have DBMS, several DBMS around the world. We have Oracle, we have MySQL, we have MS SQL. MS SQL there is Microsoft SQL. Of course, Microsoft has their own version of SQL, DBMS. Then we have PostgreSQL SQL. We have MongoDB. We have IBM DB2. We have Redis. We have Elasticsearch. We have SQLite. We have Cassandra, and so on and so forth, right? And this list that I gave to you is arranged according to the popularity as at December 2020 by Statista.com, right? So I arranged this data, or this data is arranged, or this DBMS are arranged as in terms of popularity, how popular they are, right? So you have Oracle as number 1, you have MySQL as number 2, you're doing number 2, although it's same as what you have in number 1. It's same as what you have in all of them, actually. Then you have MySQL as number 3, and so on and so forth, right? Right now, relational database. So what exactly is a relational database? Right. Remember the word relation, right? What is relation? Who can tell me? Anybody? What is a relation? Patricia, what is a relation? All right. A relation is a table. I explained this some minutes ago.
Okay,
right?
yeah, table.
Yeah. A relation is a table. And we said what? A relation. So when you say a relational database, what does, remember that we said a relation is a table, right? And we said DBMS is database management system is used to store information, right? It's the information that helps us manage databases. So when we now combine them together and say relational database management system, what does that mean? It means that a relational database management is a software that is used to what? To store data in a relational manner. A relational database management system stores data in relational manner. And what is a relational manner? Right? What is a relational manner? It says relations are actually means data stored in rows and columns. I explained that already. When you say relations, you are talking about a table. And what does that mean? It means the table is in row and column form. Basically, right? The table is in rows and what? It's in rows and column form. So when you talk about relational database, we're talking about a database management system. When we talk about RDBMS, and RDBMS is a system that stores data in rows and columns, basically. Right? They store data in what? In rows and columns. Says also the data in relational database are related to each other by what? By nature. Which means that the data are stored in rows and columns, and the data are what? The data are related to each other. Right? Data are related to each other. That is, they have a resemblance, or they have a relationship between them, right? They have a relationship between them. So that is RDBMS, right? Now, we want to talk about data models, right? Am I too fast? Please let me know if I'm too fast. Let me know if I'm too fast, right? We want to talk about data models. We want to talk about data models. Data models. It says data models are fundamental entities used to introduce abstraction in DBMS. Don't mind the English. I'm going to break it down. Right? It says data model defines how data is connected to each other and how they are processed and stored inside a system. So when we talk about data models, I'm sure you've heard about them before, but you didn't know what they mean when they talk about develop a data model, or create a data model for this data. I'm sure somehow you might have heard that before, right? So when they say create a data model, what they are trying to say is that look at this data that we have and create a relationship between this data. Help us see how this data relates with each other. And that's what we call a data model, right?
So can you say that again? Sorry.
Right? I said that a data model is defined as how data are connected to each other. How data is connected to each other and how they are processed and stored inside the system. And I said that when we talk about data model, right, we're saying that how we're trying to look at how two sets of data relate to each other. That's basically what we're trying to do. We have a data A and we have a data B, and we want to see how this data relates to each other. That's basically what we do when we talk about data models. Since the most popular data model in database management system is the relational model, right? The relational model is the most popular. So it means that there are several types. So we actually have the hierarchical data model, we have the relational model, and several other ones, right? But like I said, the relational model is the most important, or the most popular, and says that the main highlights of this model are: one, data are stored in tables called relations. That is the first thing that you need to know about data model, is that when you are talking about data model, your data must be stored in tables. That's one. Two, the relations can be what? Can be normalized. That is, we'll talk about normalization as we proceed, right? It says each role is a relation. Each role in a relation contains a unique value, right? Which means that every table is supposed to keep several rows that are unique observations of the data point. I'm going to say that again. Every table contains rows which are unique observation about that data point. Don't worry, I'm going to break all of these things down so that you understand. Right? It says each column in a relation contains value from a same word or from the same domain, that is data type. Right? So let me break each one of them to you. So actually, you actually know them, but you don't know that that's what I'm talking about. So I'm going to break them down one after the other. Right? Just watch me. Right? So take for example, right? I want to teach you how to so let's assume, right? This is our case study. Case study, right? You are the database administrator of XYZ company. No, let's use you are the database administrator for XYZ University, right? And you are asked to develop the student data point, right? You are asked to develop student data point, right? You are asked to develop information about students and create a relation for it. Develop the student data point and create a relation for it, right? So who can make an attempt to understanding what I just put down? Who can? Anybody? Anybody?
Yes,
Just make
sir.
an attempt. Yes?
Okay, I think it's sort of taking probably the math numbers, the department, this the ones that they have in similar, as in maybe the standpoint, or what did you say, unique value, should be like the ones that they have the same department number or class number or something like that. But then it's just collecting their data, math number, their department, their course. I think the standpoint is the course, because they're all studying this. The unique value should be like the course that they're studying, because maybe each of their names, they fall on the same department, and then several students fall on the same department, and several other ones also fall on the same department, on other department that has like economics, like theater art and all that. The students, maybe about 3 names could be theater art, another 3 names could be economics and all that, but with different math numbers, and different courses that they do, probably.
All right. It was a good attempt. Well done. Well done. Any other person? Any other person? Vivian has told us about idea about what she thinks this case study means. Any other person? All right. So okay.
Let me
Patricia.
try. They develop like creating their data like on a table, and like bringing their course, their different things about them, and placing it on a table, something like that.
Awesome. Beautiful. I like the fact that people have idea about what it is. So when you are in this, when you have this kind of case study, right? XYZ said university, and you are the database administrator, data whatever of XYZ university, and you are asked to develop the student data point, right, and create a relation for it, right? Now you are asked to do 2 things, right? The first thing is that you have what we call the student as your data point, right? This is called an entity, right? So we have something we call the ER diagram. Of course, we'll talk about it. It's the next slide, right? So you have the student data point. Awesome, right? You have the student data. Okay. Let me do it this way. Let me go to the next slide. Then I'll use the next slide, this slide and the next slide to explain this case study. Right. So what they asked us to do here is create a develop the student data point and create a relation for it. Right. Now, how do we do that? We want to create some sort of what we call an ER model, that is an entity relationship model. Now, what actually is an entity relationship model? We call it ER. So whenever you hear ER, just know that we're talking about in relations to database. Just know that we're talking about entity relationship. Now, entity relationship model is based on the notion of real-world entities and relationship among them. Don't worry, I'm going to explain each of these words. It says the ER is best used to conceptualize designs of a database. The ER model is best used to conceptualize designs of a database, right? Now, what is an entity? It says an entity is in an ER is a real-world data point, right? So in this situation, what is our data point? Students, right? And that is our data point, right? So in real-life scenario, our entity in this case study is the students that is our data point, right? So it says an entity in ER model in the real world is the data point. But then what is the next thing about after the entity? It says attributes. It says these are the properties of entities. These are properties of entities. Every attribute is defined by a set of values called domain. I'll explain that later. I say, for example, in a school database, student is considered as an entity, and student has various attributes like name, age, class, and so on, right? And the last one that we want to talk about is relationship. It says the logical addition among what entities are called what relationship. Relationships are mapped with entities in different ways. All right, so now that we understand what an ER diagram means, right? So we want to go back into this and solve this business case, right? So we want to create a data point, and our data point is and we want to create a data point. Yes, we want to create a relation, and our data point is student, right? Our data point is student. Right. Now, when you are creating an ER diagram, right, your entity has to be in a rectangular box like this. Look at it here, right? Entity in a rectangular box, entity in a rectangular box, relationship in a polygon, right? Polygon shape. Entity is rectangular in shape. Relationship is polygon in shape, and you have attributes are what? Are spherical or circular in shape, right? So anytime you see an AR diagram and you see an entity and you see a triangle, just know that it is an entity. When you see a polygon, know that it is a relationship. And when you see a spherical object or a spherical shape, a circular shape, know that it is an attribute, right? So we have these entities, right? This entity is student, right? Now, when we have a student, we call it the entity. Now, these students must have properties. Those properties are called the attributes, right? Properties. So what are the properties of a student? The property of a student are the characteristics of a student, right? Remember in biology, they said that living thing. So we talk about characteristics of a living thing, right? And we begin to talk about Mr. Niger D. And we say that a living thing, Mr. Niger D must have movement, M for movement, R for respiration, N for what's N again? Nutrition or something, I for irritability, G for growth, E for excretion, R for respiration, and D for death, right? I think somehow later they expanded the old Mr. Niger D, right? So it's the same thing that we want to try and do here. What are the properties? What are the characteristics, right? These characteristics are going to form our attributes. They are going to form the attributes of our entity. So first of all, a student, right, must have what we call a registration number. Right? In Nigerian school, we call it matric what? Matric number. True or false? Right? So that's number one. Two, a student must have a first name. First name. A student must have a middle name. A student must have a last name, which we call surname. Right? A student must have gender. Right? A student must have a phone number. A student must have an email address. A student must have a course that a faculty that they belong to, right? Let's continue here. The student must have a department. The student must have a department. Hold on, sorry. That's my user. Right? A student must have a department. A student must have, what else can a student have? Must have guardian or guardian, some sort of parent or sponsor, right? We'll call it sponsor, right? In what's it called? In universities or schools that have hostels, right? A student must have an hostel that he or she is allocated to.
Hello.
Hello?
Hello.
Apologies. Can you hear me?
Yes, sir.
Apologies. I need everybody to respond. Can you hear me? I know Lua, can you hear me?
Yes, yes.
Madam Anita?
Yeah. Yep.
All right. All right. Trisha, can you hear me?
Yes, I can.
I know Lua, are you there? Madam Anita, are you there?
Yes, I can hear you.
Awesome. Apologies. Network did as they used to do. Just my network just went off and just locked me out. But I'm back. Apologies. So what was the last thing you heard me say? I want somebody to tell me what was the last thing you heard me say.
You were talking about the student's entity,
Alright.
the hostel. That's what you said.
Okay. So all of these that we've done, right? All of this that we've done here, the first name, the registration number, that is matric number, first name, middle name, last name, gender, phone number, email address, faculty, department, guardian, which is sponsor, hostel, counselor, CGPA, and all of that. All of these are attributes of the entity student. And when we talk about attributes, we're talking about the properties or the characteristics of that entity. So every data point. So for you to know that this is a data point, right? You must be able to think about one, at least two attributes that particular data point would have. Now, student is able to have as plenty as this, as much as this data point, as much of these attributes, right? But there are some attributes, there are some entities that might not have as much as this, right? So take for example, you would have I'm trying to think from the top of my head now. Region, right? So if you say a region, you say a region, what will be the attributes of a region? So maybe you talk about the location, you talk about the region ID, you talk about, so basically what I'm trying to say is that there are some attributes, there are some entities that would have a whole lot of attributes, right? And there are some entities that would have very few attributes, right? But what makes an entity is that it would have at least two attributes that you can use to form your relation. Two attributes that you can use to form a relation. So now, having talked about all of this, right? We have solved the first part of that case study. Develop students data points. That's what we've just done here, right? What we've done is that we've been able to draw the ER diagram for this student data point, right? We've been able to draw the ER. We've been able to generate. We've not drawn, but at least we've been able to generate the ER properties. We've been able to generate the entity relationship properties of that student data point. Now, the next thing is create a relation for it. Create a relation for it, right? So when we talk about, I'm going to use this big space that we have here. So when we talk about creating a relation for it, we'll talk about creating a relation for it, right? Right. So when we say create a relation, what does that mean? When they say create a relation, what they are saying is create a table. Remember, table equals relation. Table equals relation. So what you are saying in essence is create a table for it. That's what you're saying. So how do we create a table? Of course, we're going to undraw this table before we go into SQL to go and begin to draw a table. So we'll undraw this table, right? So we're just going to take a few of the attributes of that student. So this table is called a student table, right? This table is called a student table, right? And the first column is what? Is a matric number column, right? Remember that this is a column. The vertical lining is a column. The vertical spaces are columns, and the horizontal spaces are what? Are rows, right? We'll talk about those later, right? So, matric number, first name, last name, matric number, first name, last name, right? What is the, sorry, right? Okay,
Gender.
let's gender. Thank you.
Number.
What else? Email.
Phone number.
Phone number. Right? Faculty and all that. So you can continue as much as you have, right? So if we call this 001, we call this Patricia. You say Patricia Omo, female, right? We say PO at gmail.com, and we say 080-132-73022, right? 02 Vivian Agbata, right? Female as well, right? And we say VA at what? gmail.com, right? And we have 08132 blah 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 blah, right? And we'll continue to fill it that way. What you have is that you've created a table, right? Of course, if you are not familiar with this, you should be familiar with this from Excel. This is how we create a table in Excel, right? Right? So what you have is that we have created with this data set that we have here, with this entity attribute relationship that we have created, this entity attribute that we've sketched out, we've been able to draw out the structure of the table, and we have also been able to fill it with what we call the rows. So these are the rows. These are the rows, and here you have all of these are your rows, right? And here you have your columns. All of these are columns. All of these are columns. Do we understand this? Rows and columns. Awesome. Awesome. Awesome.
This class still being recorded, please.
What is it?
Are you still recording the class?
Yes, we're recording. Let me check again. Yes, we're recording.
Okay.
All right. First assignment, everybody. First assignment. Right? Check I'm back, people. Network again. Don't know what's happening. What my network? Airtel has been terrible today, though. Hello, can you hear me?
Yes, sir.
Hello.
I can
Yes.
hear you.
Sorry, I'm back. Airtel has been terrible today. Really, really terrible. They usually do not give me issues, but of course, rain fell today, so Nigerian network and rain they don't meet. All right, so I was trying to give us an assignment, right? So check for 5, right? 5 data points. Are you trying to enter into class? Do that. All right, check for 5 data points at your workplace or in relations with what you do, and generate an entity attribute what's that? Generate an entity attribute information for the right. So check for 5 data points at your workplace or in relations with what you do, and generate an entity attribute information for the 5 data points, right? So like we did here, just so I'm going to give an example. Let me give an example. What do? I'm a faculty and I teach people. So I have students. So I'm going to generate, one of my data points is students, and I'm going to generate attributes for students, like we created here, right? Just generate it out like we created here. Student as an entity, attribute as listed like this. Then I also look at it and say, okay, what else do I do? I work as a policeman. No, I do not. Just using that as an example, right? And I generate attributes of policeman, right? So that is the assignment. That assignment must be submitted on or before Friday.
So how do we turn it in? Is it handwritten?
Yes. No, handwritten, not handwritten. You can just create a document for it and send it in to my mail. I'll drop my mail in on the group so that you can submit your assignment in there.
Okay, sir.
All right. So submit on or before Friday. Friday should be 10. Thereabout. Submission is 10/09/21. Right. So please turn in your assignment as soon as possible before Saturday so that I can go through them and we can make corrections. Thank you. All right. Now we want to talk about the table anatomy. Hold on, please. All right. So we're almost done with chapter 1. Right? Table anatomy. Table anatomy. Table anatomy. Please let me know. Do you understand all that I've explained so far? Are they easy to assimilate, to get? Are you getting them instantly? Do you still need more explanation? Let me know. Let me know before I move on. Let me know. Let me know. Vivian.
Yes, sir. I really have a question. I understand everything you said, but I have a question.
Okay, just note your question down. At the end of class,
Yes.
I'll take your question. Just write it down, right? Just write it
Yes.
down. Ibuko?
Yeah, I'm getting it, but I might need to go over this again.
Of course.
Maybe I might need to go over to fully grasp everything, but I'm getting a few of it. Yeah.
All right.
Yes, sir.
Patricia?
Yes, sir.
Awesome.
Yes, sir.
Awesome. Anoluapo, are you getting?
Fine. Yes, I'm okay.
Awesome. Awesome. Madam Anita, are you there? I don't think she's in class, I guess. All right. Let's continue. So table anatomy, right? So when you see a table, you need to be able to understand what the structure of the table looks like, and that's what I call table anatomy, a relational database terminology, right? We need to be able to understand the terminology that we use for tables in relational database management system, right? So a table is a basic storage structure for a relational database management system. And what does that mean? It means that when you talk about a database, remember we said that it must be information of related tables, right? So what you mean is that a single database can have one table, or it can have a million tables. It can have as much table as you want. So you look at what is the smallest form of business that you have around. Say somebody who sells shoes, right, or who sells clothes, right? Really, they do not have too much to keep. They probably keep maybe their customer details, their products, their customer table, product table, order table, and yeah, maybe just that three table, and that forms a database for them, right? Then you look at telecommunication companies, right, and you can imagine the amount of tables that they keep, right? They keep information about the calls that you make, about the text messages that you send, about the recharge card that you load, about every customer that they have, about every employee, about every vendor that they work with, about every transaction that goes through them, about every single thing, right? So you can imagine they probably have over a thousand or 3,000 or 5,000 tables that they work with, right? And you can imagine Nigeria as a country or America as a country. You can imagine the people sitting on a database of these countries, the kinds of table that they would keep, right? So Nigeria would probably keep a table called maybe citizen table, right? That contains all the information about the citizens, right? Then they will be breaking table. How many houses do we have in Nigeria? They have that kept somewhere. How many hospitals do we have? They have the details. How many schools do we have? How many universities? How many primary schools? How many secondary schools? How many roads? How many? You can imagine how many cars ply this road every day. How many cars? How many bicycles? All sort of information is kept in the database of Nigeria, right? You can imagine the amount of tables that WHO, UNICEF, all these global organizations, the kinds of data that they keep, right? So you can imagine the kind of data that was generated during COVID, right? Or that we still generate with respect to COVID, right? COVID-19 that has held the world by force, right? So you can imagine the kinds of data that are being generated. There's a lot of it, and there's so much tables that are being created every day to hold this information, right? Now, but we want to understand the anatomy of a table. What is the anatomy of a table? So we say a table is the basic storage structure of an RDBMS, right? Now, it says this image shows the content of an employee's table or relations, right? So we'll go by the numbers, right? So I want to explain by the numbers. So the first number there is 1, right? The first number there is 1. Can you see this number here? 1. And what does 1 say? It says it's a single row or a tuple. A single row or what? Or a tuple, right? It says this represents all the data required for a particular what? Employees. That is, that single row contains all the information about the employee. Remember that this table is an employee's table, right? Look at it. It's an employee's table. What is an employee's table? It's a table like our student table that holds what? Information about employees. Oh, sorry. It holds information about what? Employees. Come here. Right? Employees table. So it holds information about employees. So every single row uniquely contains information about, every single row contains information about every employee, right? In fact, in our programming, we call these an observation. Rows are called observations. Rows equals what? Observations, right? And what does that mean? It means that every entry that you have, every full entry that you have must be in a row, right? So take, for example, in this class now, if I'm creating a student row, a student table in this class now, right? Anolapo would have all our details. Anolapo will be female, project manager, blah, 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 right? That row uniquely identifies her. Patricia, Sunday, this, that, Ibuku Moses, this, that, Vivian, all of that information, so that each row uniquely identifies everybody, or it uniquely identifies each person. So take, for example, in your university, while you were in school, right, on the students database, you actually have your matric number, 1437115, your name. So whenever they are looking for 1437115, they don't have to look all over the database. They just go to that particular row and get all the information about the person who is 1437115. That is what we call a single row. It says each row in a table must be identified by a primary key which permits no duplication of data, right? And we'll talk about that later as we proceed, right? How we use primary keys to make sure that no two persons have the same matric number, or no two persons share the same employee ID, or no two persons share the same NIN or BVN, right? Or social security number. We'll talk about that as we proceed. Then the next one, which is 2, right? It says is a column or an attribute, right? A column or an attribute. A column or an attribute. A column or an attribute. In our programming, we call it a variable. A column or an attribute, right? And it says this column is a primary key column because it holds what it contains employees' what numbers, right? Now, if you look at it, we have 2 columns. We have several columns there. We have employee ID column. We have first name column. We have last name column. We have salary column. We have commission percentage column, and we have department column. But this column seems to be a special column because it holds values, right, that uniquely identify each row. Now, if you look at the values on it, the values on it are not duplicated. They are not duplicated. They are like matric numbers. They are like your phone numbers. They are like matric numbers. They are like your NIN, your national identity number, or your BVN that the bank uses. No two people share the same NIN. No two people share the same what BVN. Even if you are twins or triplet or quadruplet or whatever you are, sextuple or whatever you are, you cannot share the same account number. You must have different account numbers. You must have different BVNs. You must have different NINs and all of that, right? So this kind of row that contains that kind of information is called a primary key column. I will explain that much later when we talk about constraints and all of that. You understand that much later, don't worry. But that column uniquely identifies what? Information. So the information on it are very unique, right? Then number 3, we have number 3 as a column, right? And it says what? It's not a key column. It's not a key column means that the values inside of it can be duplicated. No, so look at this, look at the column heading. The column heading there is salary, right? 5 people can share the same salary. If you look at the data that you have on the screen, you have Nina Kocha and Lex DeHon, both of them sharing the same salary, 17,000, right? So that column can contain duplicate value. That's why we say it is not a key column or it's not a key value. It is not a candidate key value, right? That's what we're saying. So the data inside of it can be duplicated, right? The next one, which is 4, is called a foreign key column. Now, this is one of the things that gives people issues in anything that has to do with database, and I would like you to understand it. I'm going to explain it a little bit here, but when we get to it, I'll break it down so that you can understand. People usually have issues with what a foreign key column is, or what a foreign key is, right? So it says this data, or this contains data that defines how the table relates to another table, hence the word foreign, right? In when you talk about foreign key, right, it means that in that situation, we're beginning to look at two tables with respect to children. How does these two tables relate? We have a table called employees, but look at the word. Look at the title of that column. It's called department ID. We have employee ID, but in that column, we have department ID. Now, if you look at it very well and think about it, you will discover that this column, if this is an ID here and this belongs to this table, this will call this the employees table, right? The employees table. We call this the employees table. And it has an employee ID, right? And we have department ID here, but there is no, it means that this must be pointing to another table somewhere called the departments table, right? So a foreign column is a column that is referenced on another table. A foreign key column is a column from another table that is referenced on a parent table. I take that again. A foreign key column is a column coming from another table that is being referenced on a table, right? Don't worry about it. You will understand that much later. Then 5, we call 5 a field, right? A field is an intersection of column and row. It can only take one value, right? This is a field and is also known as what? Cell, right? That is an intersection between, this is a column and this is a row. This in between here, this box in between, which is what you have here, is called a field or a cell, right? And lastly, we have number 6. Number 6 here, it says is a field with no value in it. It is called a null value field. That is when you have a field that does not have value in it. Look at this one here. The one here has 60. This year has Raj. This year has Davis. This year has 3001. But this year, right, don't mind the null in bracket. Null actually means unassigned, right? Null value means unassigned, right? Or unavailable. So what we are saying is that the data is not available, or the data is not assigned. Please give me 1 minute. Please give me 1 minute. 1 minute, please. Sorry, I'm back. My generator was trying to do somehow. All right. So null value.
Sorry.
Yes.
Not a question. There's something you mentioned, but I didn't catch it. You said for number 2, that the column one or the attribute that in programming is called what?
In our program, it's called variable. Variable.
Okay. Thank you, sir.
Right. So null value means unassigned or unavailable, which means that, so take for example, not everybody in the company earns a commission, right? It is only people in marketing or in sales that earn what? A commission, right? So for those who do not earn a commission, would you put 0? No. That means that the fact that they don't earn commission today doesn't mean they cannot be transferred to sales department. The day they go to sales department is the day they begin to, is the day we assign a value to their commission percentage instead of 0, right? Because if you use 0 in a arithmetic, in an arithmetic operation, right, what you get is probably 0. That is, if you multiply 0 by their salary, then you get 0, right? But when you use a null value, right, we can manipulate null value, and you'll see as how we do that as we proceed, right? So we're going to go all over this again. So number 1 is a single row, Number 2 is a column or an attribute or a variable, right? Number 3 is not a key value. That is, it's a column that does not contain key value. That is, the values inside of it can be duplicated, right? Number 4 is a column from another table that is referenced on this table, right? Which is called a foreign key column. Number 5 is a field that contains that only takes one value, which is an intersection between what? The column and the row. And number 6 is a field that has no value, and it's called a null value field, right? If you open your Excel, right, it's the same thing that you have in your Excel. Awesome, right? Now, don't worry, today's class is not going to be stressful.
To ask a question.
Okay, please go ahead.
Number 3. Why is the column not a key value? I didn't get that.
Okay, the reason why the column is not a key value is that the value, when we say a key value is a value that can be used to uniquely identify a row. A key value is a value that can be used to uniquely identify a row. So take for example, if you look at this data, we have employee 107, right? Employee 107 is Diana Lawrence, right? There is no other than, if there's any other Diana Lawrence in the company, right? She would not be 107. She'll probably be another number, because 2 people cannot be 107. That is the key value, which means that value cannot be duplicated. It's like your matric number. It's like your BVN, right? That is for a key value. But when you say a value is not a key value, it means that column can contain duplicates, right? So take for example, salary. 2 people, 10 people, 100 people can earn the same salary in the same company, right? So that's why we say that it's a column, but it does not contain a key value. Do you understand?
Okay.
Yeah.
Yeah. Thank you.
Yes, ma'am.
So sorry, can
yes.
a row also not contain a key value?
Can a row also not contain a key value? Actually, in the real sense of data, of relational database, right? You see this relation can be normalized. That's what they're trying to say, right? When you talk about normalization, what you're saying is that each row has to be unique. Do you understand what I'm saying? Each row has to be unique, right? Which means that there must be a key value for each row.
Okay.
Do you understand what I'm saying? So for whatever database you are trying to create, for whatever table you are trying to create, as long as the observations in that table are going to be different, that is, the rows are going to be different, right? Then they must be unique in the way. And the reason why they must be unique is that we want to be able to access them easily. So imagine that, do you know how many Vivian Agbata are in Nigeria, right? So imagine that one Vivian Agbata went to kill somebody in Edo. But of course, you are Vivian Agbata, and they come to Lagos and they say, who is Vivian Agbata? Somebody points to her and they say, that is her. The fact that you share the same name doesn't mean that you perform the crime. So what happens? Even God, what God did was that even God did uniquely identified us. God knew that we're going to carry, all of us are going to be, only when I was in secondary school, we're about, in my class, we're about 20 or so that bears shame, right? So when you come to class and you shout shame, we are plenty that will answer you. But when you come to class and you say number 10, there is no other number 10 in that class except for me. So when they are calling the register, our class teacher doesn't use our names. They just call your number. Number 10, present. Number 1, present. Do you understand what I'm saying? Because it uniquely identifies each person. So it's like a name tag that you're carrying around. It's like a barcode that you're carrying around. Once they look for your matric number, once they get your BVN, once they get your NIN, they are able to get more information. We can use that to get more information about you from the database. Do you understand? Therefore, every value, every table must have a column. In fact, usually the first column that uniquely identifies the row, right? When you have a table, it is possible to have a table that does not have unique values. But in that situation, it would not be a relational database. Are you following me? Because in that form, in that sense, it does not, it's in an unstructured way. It's an unstructured data. It's a data that's going to give you a problem. Do you understand what I'm saying?
Mm.
Do you understand?
Yes, sir.
Awesome. 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 All right. Now we want to look at MySQL as a database management system, the client and the workbench, right? Now, we're going to be using MySQL, right? Most of you actually have it installed already, and this is what the interface looks like, right? You can pop it up. After class today, I'm going to send you a code that we're going to use next class. Probably I'm going to send it during the week so that we get it ready for next class, right? And we'll talk more about it once we understand it, right? Now, what MySQL is, right? Remember we talked about what was it called? Database management system, right? And we said there are several database management system available in our world today, such as Oracle and MySQL, right? This is the MySQL interface, right? This is MySQL interface. And since MySQL is a database management system that allows you to manage relational databases, right? It is open source. It's an open source software backed by Oracle, right? So MySQL is a relational database management system. And what do we say relational database management system do? They can help us store information, store data. They can help us retrieve data, and they can help us what? Manage or modify what data. Please do not forget, a DBMS is actually a popular interview question, right? A DBMS, what can a DBMS do? It can help you store data, it can help you retrieve data, and it can help you modify data. It's as simple as that, right? And we say that it is open source. When you say something is open source, it means that basically it does not have an owner, right? When we say something is open source, what we are saying is that in the real sense of it, it is owned by everybody. It does not really have a owner, right? Even though somebody created it, the person who created it has made it public property, right? So anybody and everybody can lay claim to it. But of course, not so that you can just wake up one morning and say, I'm the owner of MySQL. They will shoot you, right? Even me, I will join the people that will shoot you, right? So, but the software is backed by Oracle, which means that Oracle takes, they won't say that they are the owner because they didn't create it, right? But they are the ones who maintain it, right? That's why we say backed. They are the one who maintain it, right? It was maintained by Sun Microsystems before. That's the owner of Java. Then Oracle bought Java. That's Sun Microsystems. And one of the things that they bought alongside with it was, I think that was in 2010, was MySQL, right? So Oracle owns Java now. They own Sun Solaris and they own MySQL, right? So it is backed by Oracle, and it says it means you can use MySQL without paying a dime, right? How many of us paid for it when we're installing? No, I just told you, go to this place, download there. Once you download, then we install. Nobody asks us to pay €1. You cannot use Microsoft. Of course, only in Nigeria do we use Microsoft without paying, right? But don't say that I said that to you, right? But across the world, you do not pay for for MySQL because it is open source, right? And also, if you want, you can change its source code to suit your needs, which means that you can create your own variant of it, right? Tomorrow you can say that you want to create a Vivian SQL, right? All you just need to do is just download the source code that was used to create MySQL and adjust a few things, and it becomes something. It becomes a product that you can also ship across the world, right? So it says even though MySQL is open source, you can buy a commercial license version from Oracle to get premium support services, right? Now, what Oracle has done is that, of course, MySQL is open source, but they have created a version of it that you can pay for, right? And if you go back to that website where you download, they are enterprise versions, right? Enterprise versions means that versions for organizations where they have added some support services to it that makes it more robust. But basically, in the old structure of what the software can do, you have the full version of what the software can do with you on your system, right? Since MySQL is pretty easy to master in comparison with other databases like SQL, I mean, in other database softwares like Oracle database or MySQL server. True, right? True. And the reason is because most of the things in MySQL has been simplified, right? Because it's open source, right? Oracle is a ton of complexity on its own, right? And Microsoft is not bad as well, right? So, but MySQL is simpler. And remember, I've said it, or if I've not said it, I'm saying it for the first time. SQL is the same thing across board. What does that mean? It means that the SQL that you run on MySQL, if you get to Microsoft SQL, it is the same language. If you get to Oracle, it's the same language. If you get to Postgre, it's the same language. If you get to Redis, it's the same language. If you get to MongoDB, it's the same language. It's the same language across board, right? It's the same language across board. It's the same language across board. The platform might just be different. The interface might just be different. But usually, even the interfaces for it are they usually look alike, right? The interface usually look alike, right? So don't be scared, right? When you learn MySQL, what you're learning is you're learning database for all, you're learning the language for all SQL database, DBMS all around the world. So if you find yourself in an organization where they use Oracle, right, all you just need to do what you would not know is the administrative part of it, right? Which this course does not even cover. The administrative part of it, you might not know. But the SQL part of it that makes you a developer, that makes you a database administrator or whatever, you would know that, right? You'll be able to work with that. That is how that works, right? The administrative part of all of these guys are more complex, right? It's not something we can do in 6 weeks or in 8 weeks or in 10 weeks. They are more complex and they are not general skills that everybody should have, right? But the SQL itself, having to manage the database, having to work with the database, it's a skill everybody should have, right? MySQL can run on various platforms: Unix, Linux, Windows, Mac, and all sorts, right? So you can install it on a server or even a desktop. Besides, MySQL is reliable, is scalable, and is fast. It's very beautiful. MySQL actually supports about 70 to 80% of every database on the internet, right? Every database on the internet, every web database. Let me say that way. Every web database, about 80% of web databases are supported by MySQL. So you can see that it's pretty awesome. So what does that mean? It means that if you find yourself in Jumia tomorrow, right, as a company, as a data analyst or a database administrator, you're able to work because they use MySQL. If you find yourself in Konga, if you find yourself at Alibaba, you find yourself at Walmart or Amazon, right, they use the same SQL, right? So it's that awesome. And you can download MySQL from what? From the MySQL download MySQL server, community server, right? That is the link. The link is on that slide. Once you click that link, it will take you to where you can download MySQL, right? So this is the interface, right? You have the interface. I'm going to be explaining the interface tomorrow, so I don't want to bombard you this night. And lastly for today, I don't want us to rush this, although we're going to increase our pace starting from tomorrow. But then, like I said, the introduction, I want us to understand the introduction. So I'm going to stop here and take questions so that we can understand better. Right. So database schema. A database schema represents the logical configuration of all or part of the relational database. It can exist as both a visual representation or a set of formulas known as integral constraints that governs the database. A schema is usually made up of objects such as table views, constraints, indexes, sequences, synonyms, and so on. Right? A database is usually made up of several schemas. Now, so don't mind the fancy English. Right? Let me talk about what a schema is. Think of a schema as your room, right? I like to relate these things to what we know. So take, for example, in your house, right? If you are not married yet, or even if you are married, right? You have everybody in the house, you have your room, right? And in your room, your father has a room, your husband probably has a room, or you and your husband share a room. You have your room, the room for your children. If you are living in your father's house, you have your own room. Your father has his room, your mother has a room. Everybody has their room, right? Now, in your room, you have your bed, you have your mattress, you have your wardrobe, you have your clothes, you have your shoes, you have your bedroom, you have your toothbrush, you have your toothpaste, you have everything that pertains to you, right? Your perfume, everything that you hold is in your room, right? Now, what does that mean? It means that for anybody to come and take stuff in your room, they need your permission. Are you following me? Now, it's the same thing that we have on a database, right? The database is made up of schema, right? A schema is a logical configuration, right? When we say logical configuration, which means that it is not physical, it is virtual. It's not physical, it is not virtual. Don't let me use the word virtual. It's logical. Logical in the sense that it exists based on logic, right? Which means that there is no physical location to it. But let me explain what logical configuration means to you. So on your system, you have an hard drive, right? And on that hard drive, you now have several folders. You have a folder for music, you have a folder for movies, you have a folder for your document, right? Now, those folders are logical partitions. Your hard drive is your physical partition. If your system gets spoiled, what do? You remove your hard drive. That's your physical partition. You can hold that. That is tangible. But your music, where you stored your music into, even though you name the folder my best music, they are not tangible. They are logical, right? It's the same concept that we have for database schema. So inside a database schema, you have the tables that you are creating. You have views as database objects. You have constraints. You have indexes. You have synonyms. You have sequences and all of that. All of this you would understand. But think of a database schema as a partitioning that contains everything that is pertaining to the database, right? Everything that is pertaining to the database. We'll be working with schemas as we proceed, and you will understand how to create a schema, how to create the objects in a schema, right? Right. All right. So tomorrow, we'll be talking about SQL, right? And what are the components of SQL and how to start and where to start with SQL. So tomorrow, get ready. You'll be starting to write queries tomorrow. We'll be creating tables starting from tomorrow. It's very interesting, very interesting. Do not miss tomorrow's class. Please, I think we've come to the end of today's class. So if you have questions, I know that a few people had questions, and I asked you to write down your questions. So this is the time to ask your questions. You can just unmute yourself and ask your questions. All right.
Sir,
I'm waiting for your questions.
The assignment.
Yes.
Just pertaining to the assignment.
Pertaining to
the assignment you gave.
Yes. The assignment. Okay.
Okay. So, are we expected to like list out all of the attributes of the data point and then are we creating tables for them?
No.
Okay.
Tables. Yeah, you're just listing them.
Okay, sir.
Yeah. Any question? Madam Anu, Mr. Ibukun, Madam
I wanted
Patricia.
to ask that, would you say that SQL is a cloud platform?
Okay. Now, all right. So SQL is, yes, all the cloud platforms now have SQL as one of their components, right? Now, when it comes to cloud computing, right? Cloud computing is that you're storing your information on a system that you do not know where it resides, right? That's basically what cloud computing means. And the essence of cloud computing is such that we can take away the burden of having to own resources, having to own hardware resources, right? Taking that away from us, taking that away from end users. That's the essence of cloud computing, right? So you have organizations that have invested heavily in hardware resources, right? And they are ready to share their hardware resources with you, such that you can store their information with them, and they keep it safe for you. And of course, you'll be able to access your information at every point in time, at every time that you need them. So that's the essence of cloud computing. So as part of what cloud computing does is that, and this is what cloud computing, I used to tell people, think of cloud computing as your personal computer that you do not have physical access to, right? Now, if you can install SQL on your physical computer that we just installed, right? You can also install SQL on a cloud computer, right? They can provision a space for you in your on your server, on the server that is allocated to you, and you install SQL. So SQL as a software becomes a platform, or platform as service or infrastructure as service, right? Software as service. That's what they call it, right? Or that's what we call it, right? So yes, SQL is one of the components that you can use on cloud, right? But SQL on its own is, of course, SQL is a language that we use to work with databases. So which means that in cloud, you have databases on cloud. And once a database is in cloud, right, you can use SQL to access it. So basically, yes, you can use SQL on the cloud.
Okay, thank you.
Yeah. Any other question, please? Any other question? Iboko?
No questions. Thank you.
All right. Patricia, any other question? That question.
Please, this query, you said query is a device that has the ability to connect to the internet.
A query?
So, yes, query.
No. All right. Let me go back to where we talked about query. Yeah, right?
Yes.
Now,
Please, can you just like
explain what a query is, right?
yes,
Is that
yes.
okay? Now, a query is a question, right? A query is a request, right? Think of a query as a request that you send from a client system to a data server. Tomorrow, I'm going to break this down a little bit more so that you understand it, right? A query is a client system. Take, for example, you just asked me a question right now, right? You asked me a question.
Yeah.
What you did is that you queried me.
Okay.
Do you understand? You queried me and I'm giving you a result, right? Now, in SQL, we just use SQL to write that query so that the database can understand. SQL is the language. You queried me in English language now, right? You used English language to ask the question. Now we are using SQL to write the query to the database, to ask the database questions so that we can get a result. That's basically what a query is.
Okay.
Yeah. Right. Don't worry, you'll be writing queries very soon, very soon, very soon. Right?
Yes, sir.
Yes. That question. All right. In the absence of question, I want to get a feedback from everybody of how the class went. Just give me a feedback, and I want everybody to give me a feedback. Just tell me how the class went. Was it well explained? Was the concept well explained? Do you understand the concept? Was I too fast? Just tell me what comes to your mind. Just be very, constructive so that I can serve you better by tomorrow. All right. So I know Loapo, can we start with?
Oh, wow, but my name starts with A, Abby.
Yeah, you know.
Okay, so I was just saying to myself now that I the class is very explanatory. I like the way each because I've been in classes and then sometimes you're speaking over my head and I don't understand what you're saying, but the way you're able to break down even the like tiniest of words has helped me to understand this concept better.
Awesome.
So, yes, so that's it. And I like the fact that it looks like a classroom where you can write on the screen and all of that. So yes,
Oh.
I'm able to, but even though when I started this class, I was dozing because I slept off. That's why I came late. So I was able to still get all of that.
Awesome, awesome, awesome. I told you that my class at Avita, we try to simulate the real life scenario as much as possible. Bring real life classroom to virtual classroom. So it is not the way people handle online classes. Well, that's why we don't call it online classes. We call it virtual live classes, right? And everything that you do in classroom in the class we'll do here, right? You can talk to me. I can pause and talk to you, explain to you. You see my face, everything. The only difference is that we're not in the same room together, right? We're not in the same room. That's all. So thank you for that feedback, Patricia.
Yeah.
Sir, yes,
Yeah.
sir. I enjoyed the class and then also to understand everything you said today. And I like the fact that you're just taking it words by words, like you're not using big English words. And that's nice. I want it to continue like this so that we can all do and all that. Yeah, it's fine.
All right. All right. Thank you. Thank you. Awesome. Awesome. Thank you for that feedback. Thank you. Ibuku.
Yeah, for a novice in what all this is all about, I think I enjoyed it, and it was not it's not looking as strange as I thought it would, because it's well explained. Even though, like I mentioned earlier, I'm going to have to go over the videos all over again just to be able to ensure that I do not miss anything out again. But apart from that, it's a yeah, and then the screenwriting. I was going to ask you what software you use for that, because it's kind of new. I'm not
It's
sure
kind
that
of
this is the first time I'm seeing that kind of stuff where you teach online and then you're able to write on the screen. Yeah, I was going to ask what you use for that. Yeah.
you want to know my secret. All right. I actually use an hardware. I use an hardware. Uh, I use an hardware to do that.
Okay.
I have a this drawing pad that they use for drawing stuff, the digital drawings, right? Is what I
Okay.
use. Yeah.
All right. Yeah. That's it.
All right. Awesome. Awesome. Thank you.
I look forward to
Vivian,
tomorrow. Sha.
what do you say?
I'm looking forward to tomorrow. That's where the gist is.
Don't worry. The classes are going to be the same. They're going to be awesome like that.
Yep.
All right. All right. Vivian, is she there? Is she giving us our
Yes, sir.
feedback? Yes. I'd like to get feedback from you.
I've been having classes with you, sir. So it's also that's the reason I subscribed for this. You've always been a super good teacher, honestly. And I mean, like I said the first day, you're a life coach, you're a guardian, you are everything. Like I don't think anybody is gonna get bored of the class and is gonna regret having this class with you because you've always taught me. Not just physically. I think there was a time during the COVID we had some virtual online classes. Yeah, network sometimes because of where we are, Nigeria, used to be a hitch, but I think you try as much as you can to give us the best. at the end of the day. So I enjoyed the class. I've had an intro part of this SQL why you were teaching us in, not you, actually one of your people that are under you, you were managing. It wasn't this deep, honestly. It was too fast as well. You try to cope. The first time I was introduced to it, I was like lost. Like I don't know what this is all about, and I was trying to, okay, let me catch up. But I mean, you're breaking them all down, and it's interesting. I look forward to more of the class. Thank you, sir.
Awesome. Thank you. Thank you for going in details to hearing to giving us feedback. Madam Anita cannot give us feedback. I don't know why she cannot unmute herself, but please help me type your feedback in the group so that we can yeah, see your feedback. Can see your feedback. Thank you guys. Thank you really so much. I really appreciate it. I'm sure that you guys can recommend Avita and you can recommend me and my company to other organizations, to other individuals and to organizations, and so that they can enjoy everything that you are also enjoying it. So, and yes, please, if you have people who have doubts, who wants to join that, who have doubts, now you can see that the doubt has been cleared. They can still join the class, right? They can still join the class. They can still join this present class that is going on. So please, if you have people who are interested in joining, help me advertise so that they can join, so that we can increase the number a little bit more. Thank you guys. Thank you guys. The videos, I'm going to drop the videos. I'm going to drop the link of the video with you on the group so that you can download the video and watch, right? So the videos are your property that we give to you, or they are property from us that we give to you. You can download and watch for at your leisure or at your free time. Understand the concept. Please and please, this is a lifestyle. This SQL is a lifestyle. Technology is a lifestyle, right? Career in tech is a lifestyle. You have to be able to, you must decide to be able to live the lifestyle, right? So that that is the only way you can learn it, right? And I usually advise people 1 hour, 30 minutes every day goes a long way, right? 1 hour or 30 minutes every day goes a long way. So what you just do is schedule at least 1 hour every day to practice what you've learned, go through it, practice it. And before you know it, if you do 1 hour on several technologies for 6 months, trust me, you're going to be a genius, right? You're going to be a genius, right? So please and please don't just forget this while after this class, right? Download the videos. I'll also drop the slides with you so that you can go through the slides as well. Download the videos and watch them. You can also do your research online to be able to check for more resources about the topic, right? And if you look at it, as we're going forward, like I said, the essence or the way we created this program is such that you would not have to do too much of reading. And discover that the challenges that people have in this life is reading, right? And that's why I'm bringing in the practical aspect of this training, so that you don't have to do, you don't have to read, right? Once I show you, once I explain to you the syntax and the way we write SQL languages, you would be able to do by yourself, right? And you being able to do, you must be able to do. And if you do it the first time, you do it the second time, before you know it, you have memory, your cell memories begin to understand all these things, and you begin to practice them more and begin to understand them physically. That is how this works. So please, and please, at least 1 hour every day would go a long way to helping you, right? Thank you so much. We've had 2 hours, 24 minutes of class. I would like to draw the curtain of today's class here so that we can all rest. Tomorrow we meet by 3 and we end by 8. So tomorrow's class is going to be a bit longer. So please prepare your mind so that we can cover, you know, that we have, this is our second week of 8 weeks, and we have a longer journey to go, right? I don't know if you have shared the curriculum with us, but if I've not shared the curriculum with us, I'm going to drop the curriculum in the group as well, so that you can all have your curriculum and follow through on the curriculum, right? So tomorrow's class is going to be a bit longer than this. Prepare for it. It's going to start by 3, and we're going to do at least 4 to 5 hours of class. The last set that did SQL, We usually start by 2 and finish by 8. They usually have 8 hours class, 6-hour class every Sunday, 3 hours every Saturday, 6 hours every Sunday. But I'm just trying to ease us into this gradually. Although we might also have to increase the timing as we proceed. But tomorrow, please prepare for 5 hours class. But since it's interesting, at least it's interesting and engaging, right? You would not fall asleep. And of course, please have your system in front of you so that you can practice as I give you room to practice, right? Thank you. Thank you, everybody. God bless you.
Sorry, I just have one contribution.
Okay.
Okay, let me use my guys. Sorry, just trying to, for people that said they were falling asleep, I was part of it. From the beginning, I was falling asleep. That's because I was lying on my bed, facing my system. But at the time, I noticed I was falling asleep. So I had to stand up to go and sit, carry a chair, sit down and look at the system. So I feel that way, sleep will not come.
Yes,
Thank you.
please, you cannot take the classes while lying down. Come on.
Yes, I noticed
Be a
myself.
Christian. Be a Christian. Don't take classes while lying down. Come on. You will sleep off. There's no way, no matter how interesting. Have you ever seen a movie while lying down before? No matter how much Jason Statham
Uh,
and everybody wants to try, you will sleep off.
some of
Right?
I
us
did.
are pros at lying down. I can walk 8 to 5 lying down
Are
and
you
I will
serious?
not sleep. Yes.
Legend. Yeah.
No, that's good. I did. I almost
Beautiful
slept off.
mama.
I had to sit.
Oh, thank you.
Thank you.
All right. All right. Thank you, guys. Thank you, guys. Just do what works for you, right? Do what works for you. Put water beside you. Put a drink, maybe an energy drink or sugar drink, whatever. Just do what works for you, just so that you get the best out of the strength, right? Because at the end of the class, you're going to be doing a capstone project, which encompasses everything that you're going to learn, right? You're going to use them in this. So please and please just try to, and also engage on the group, right? I want discussions from you guys on the group so that people can see and join in, and you can learn from each other. Not just learn from me, you can learn from each other. So do your research, bring your questions into the group. You can also reach out to me anytime. I would answer your questions. But basically, just drop your questions, either majorly, if it's an SQL question, drop it on the group, let people attempt it, then I would finalize on that question. Thank you for coming. God bless you. I sign out now. Whoa, my video was not on. Don't know why. All right, I sign out now. God bless you. See you out tomorrow. Kisses.
Bye.
Bye.
Good night. Bye-bye.
Bye,
I
sir.
already saw a job. I already saw a Google job that is
Are you,
requiring experience. I was
oh
reading
yeah,
through the job description today. I was gingering myself.
are you serious? Oh yeah, apply before they begin to
Send
sort.
us link too.
Because they say you should share the link. Before
I'll
they
share it
Exactly.
on the
Your
chat.
sister help.
before they begin to sort CVs and all that, you'll be an SQL developer by then. So yes,
So,
apply. Put in your
yes.
CV. Yeah, you look
All
at
right.
if you need heads up on how to add SQL to your CV, just chat me up or look at my profile on LinkedIn. You should be able to get some
Okay.
from
All right.
the not just from there. Yeah. All right, guys. Take
Yeah,
care.
bye.
Madam Anita, I missed hearing from you. Please, we need to work on how to unmute your mic. Right? But we'll do that tomorrow. We'll probably do a test tomorrow afternoon before class starts. See you guys tomorrow. Bye.